So what's your topic for today? I forgot. I have assessments and psych stats. What's the top? Hypothesis testing using t statistics. So here's my lessons. Step one. Wait, what? How, how did it happen? Seriously? I don't get it. Ah, yeah. What's the use of internet? I should search some examples. Well, nothing's wrong in searching. I should be. I'm gonna get my phone.
Hi there! Here you will learn how to perform the independent t-test. Welcome to our vlog. I hope you are as ready as I am to start learning and have fun.
A t-test is a type of inferential statistic used to determine if there is a significant difference between the means of two groups, which may be related in certain features.
It also saves a huge amount of time since the small sample size is needed for calculation. It leads to good control of individual differences and can result in less noise of data.
First, we must know the requirements needed to perform the independent sample t-test. Our assumptions are there must be two independent categorical groups that represent the independent variable. Secondly, our dependent variable should be normally distributed. Lastly, the variance of the two groups should be equal in the population. An example problem we have is there any significant difference on the hours of sleep between female and male? Our null hypothesis would be there is no significant difference on the hours of sleep between male and female, while our alternative hypothesis is there is a significant difference on blank blank blank. The independent variable is gender, with our samples being male and female. Dependent variable is the hours of sleep. Our alpha would be 0.05 in a two-tailed test. After analyzing the given data, we can now compute. Here are the following formulas to get the t obtained. First, you need to get the variance, then the pooled variance, and the standard error difference. This is to give you the values needed for the t obtained formula. If it's too long of a process and your calculator can handle a two-line display, you can use the combined formula instead.
The population size for this example is 14. To get the summation of the first set, we need to add the first set of males, which is equals to 50. Then the n here represents the sample size, which is 7. To get the mean of the first sample size, we need to divide the sum of the set of males to the sample size, which is 7.143. Lastly, square the set of the first sample, then get its summation. Repeat the same process for the set of females. We will now proceed to compute the following. To get the population variance, we need to use this formula. Subtract the summation of the squared set to the sum of the set divided by the sample size and divide it all by the sample size minus 1. And for the pooled variance, we will be using this equation. The number of scores in the first sample minus 1 multiplied by the estimated population standard deviation of the first sample squared plus the number of scores in the second sample minus 1 multiplied by the estimated population standard deviation of the second sample. Divide all by the difference of the number of scores in the first sample minus 1 plus the difference of the number of scores in the second sample minus 1 also.
For the standard error difference, you may use this formula. Square root the S-pool variance multiplied by 1 over N1 plus 1 over N2. After computing for the population variance, pool variance, and standard error difference, we can now find the t-stat. To get the t obtained or t-stat, you may use this formula. The difference of mean 1 and mean 2 subtracted to the difference of population mean 1 and population mean 2 over the computed standard error difference. Since no population mean is given in our problem, it becomes 0. Then you may equate the following. Using an advanced calculator, later, you may use this combined formula instead. The combined formula is the difference of mean 1 and mean 2 subtracted to the difference of population mean 1 and population mean 2 over the formula of the standard error difference. It will bear the same result.
To know the degrees of freedom, you need to get the difference of the number of scores in the first sample minus 1 plus the difference of the number of scores in the second sample minus 1. Based on the degrees of freedom, find t-crit to test for the hypothesis. We will be using the alpha 0.05 two-tailed test.
The t-crit can be found online by searching up the t-table values. Align it with your degrees of freedom as well as your tail test and your alpha.
T-crit is equals to 2.179, which is greater than the t-score 0.366. We will be accepting the null hypothesis.
And that's the end of our vlog. I hope you learned something new today. Thank you for watching.